Great, thank you. Right, so what we'll do is break the course down into sections, and at the end of each section there'll be an opportunity for you to have a go at what we've gone through, and ask any questions about that. Then if you want to post your questions in the group chat, then we'll go through those at the time, and if you've got any sort of off-topic questions that would, not about the section that we're actually working on, if you put those in the chat as well, and we'll try and get to those at the end. And also do feel free when we're doing the activity, if you want to just unmute your mic and call out any questions, that's fine too. Right, so first of all, just a really basic thing about pods is, although they're passive acoustic instruments, they don't record sound in the way that wave file recorders do. They're recording high resolution information on the clicks themselves. So we're only interested in high frequency clicks, and the device records this very high resolution information on the clicks and the waveforms that make up those clicks. And by doing that, we record a lot more information about what we're interested in and a lot less ambient noise. So that means that we have much lower data volumes, and also much lower power consumption. Both mean that we can run for much longer periods than if we were just recording everything. So that's one of the big advantages of pods. So I'm going to share my screen, and we'll just check that everyone can see that. Yeah, also hopefully you've had a chance to download the software and download the data files that we've sent you. The software, we gave you 3 different resolutions, and hopefully you've found one that works for your screen. It's very difficult to write this kind of software that suits everyone, so we've actually written it as three different resolutions. The functionality is identical, it's just how it renders on the screen. Okay, so the first thing we're going to do is assume that you've taken your pod out of water, you've stopped it, you've taken the card out and you've put it in your computer, and you now want to get that data off and look at it. So everyone able to see my screen all right? I'll assume you can unless you say otherwise. Okay, so if you can see my cursor here, we're going up to this read SD card. Also read SD, it actually says. So like I said, there'll be an opportunity to have a go at this when I've finished talking. So really important thing is how you name your files. So you want to name them in a way that you can identify this deployment. The software will add in the date of when the device was switched on, so you don't need to worry about putting the date in, but what you do need to do is give it a name that you'll recognize in your data. So that can be a location or a particular deployment name. I'm going to call it Bark House, which is the building that we build them in. And then you can fill in this other information if you want to. I'm not going to here. So we go to this FPOD read SD card. We click that, and I'm now going to go to where I've saved the sample data. So it doesn't matter that this is exactly the same data that you've got from the download. It doesn't matter which one of these files you click. So this, if you imagine you browse to your SD card that you've taken out the pod, and then just double click. I'm going to click the first one. It's then going to ask me where I want to save this file, and the file that I'm going to save is a thing called an FP1 file. And I'm going to save it in the same location. On your computer, you'd browse to a folder on the computer. You wouldn't save this to your SD card, you'd save it to your computer. So I'll click that, and in a few seconds, it will go through 9 days or so of data. So that's done. So first of all, what is an FP1 file? It's the file that contains all the clicks from your deployment. So it doesn't contain any sort of context of what those clicks mean, but it has all the information that the software needs for the next process. But at this point, we just have an FP1 file, has all the clicks in it. So the next thing we're going to do is get the software to try and find trains of clicks. And by trains, I mean clicks that it thinks are connected. So obviously what we're interested in is clicks that come from citations. And when a citation clicks, it will click a number of clicks in a train, in a sequence. And the software will try and find those. So it will find citation trains, but it will also find boat sonar trains because the clicks from boat sonar are citation-like. So that's why it's recorded them. It's not that we're actively trying to record boat sonar, but that's just a function of how the system works. Okay, so what we do then is we go to this trains tab here, click that, and then down here there's a button that says detect click trains in FP1 files, and we click that one. And then all we do is double click on the FP1 file that we just created. I'm not actually going to click open because it takes about 1.5 minutes on my computer to generate that. And I've already got the FP1 and FP3 file, which you guys also have from that download that you have on your computer. So I'm just going to click cancel. But what happens, you click it, you get lots of kind of flashing graphics as it makes its way through the train detection process. So let's just assume that I've done that. And this is what I would end up with. So no, we haven't covered much, but we've covered enough that I think it's worth you guys just having a quick go at that. So if you want to just go through creating the FP1 file, and if you want to create the FP3, then do that as well. Just give yourself a couple of minutes for that process to run, and then we'll come back in a few minutes' time. And yeah, do post any questions. I can see there's a couple up there already, and we'll get to those as we go. Okay. So Robertus has asked, is there a reason for date in file name jumping to year 1899?
Nick's actually answered that,
yeah.
just so you know.
Oh yeah, there was a delay, it's popped up now. Okay, so you can all read that in the group chat. Yeah, Nick, do you want to answer that one from Anne-Marie?
Deployment meters, yeah, you're right. Yeah, I mean, people don't often fill it in, but if you wanted to look at what difference it made, how high above the seafloor it was, be really useful to have that there. If you didn't put it in, but you kept a record of it, you can add it later, so that's useful.
So we'll just give you a couple more minutes on that before we move on. And I just want to give everyone the opportunity to find any problems they might have using this on their own system or anything that I haven't explained.
Yeah, we just have a question here on this end. My name is Jason. I'm with Sustainable Marine over here on my right-hand side. This is Ben McKay. We're going to be doing the training here together. What we're trying to do right now is, I guess we are looking at the sample files that were provided for the training, and there's 2 files in there. And I suppose what we want to do is open up the FP1 file, and we do that by clicking on the Trains tab. Is that correct? Or is that
No. So what we were just going through was how you first create an out. So the FP1 and the FP3 file that you've got in your download, they're there so that you've already got those files, that you don't have to do this step. So if you did what I was just showing you in that first section, you create the FP1 file and then you use the Trains tab and that button to create the FP3 file from that. And yeah, so what we'll do now is move on to how you open those as a set. But I just wanted to give people the opportunity to see how you actually make those files yourself. So you can do that if you like, but totally fine if not, because like you said, you've got those files there ready to go anyway.
Okay, we were trying to generate the FP3 file, but we can just move on. Yep, that's fine.
Yeah, cool. Yeah, all you do for the FP3 file is so you've got the FP1 that you've created from that data, and then you go to the Trains tab, and then you go down to this Detect Click Trains in FP1 files, and then you browse to that FP1 file and select it, and that will then generate the FP3 file. And that process on my computer, it might be different on yours, will take about 2 minutes to do that. So feel free to skip that, and we can move straight on to what we do with them.
Perfect. Yep.
Okay, cool. So I'm just checking the questions in the chat. Okay. Okay, if everyone's happy, we'll move on. I'm just going to go from the point of view of you've got the files, but you haven't opened them. So first thing we're going to do is go to the Files tab, which you may already have selected. So hopefully you can see my cursor there. This lists the files that you have open. So this in itself can be a bit confusing. Generally what you're opening is a set of files, and a set is an FP1 file and an FP3 file. So you've got the FP1 file that gives you all the clicks, and you've got the FP3 file. Sorry, I did say the FP1, didn't I? Yeah, FP1 file that has all the clicks, and then you have the FP3 file that just has the information about the click trains and their classification, as well as some other parameters. So when you look at it, the FP3 file looks like a filtered view of the FP1 file with the train information added to it. So this screen allows you to open a number of copies of each of those files. So that's what we do here. So it says open FP1 times 1, open FP3 times 3. That's just a default that we've put in. You can open a total of 6 files or 6 copies of the same file, depending what you want to do. So if I leave those at their defaults, so we've got FP1, 1 of those, and 3 copies of the FP3. I then go and click this open file set, and then I'm going to double click on, it doesn't matter which one I click on, I'll just double click on the FP1, but if you double click the FP3, same thing will happen. So I've now got, if you look down here, I've got 4, 3, 2, 1. I've got 4 files open, and the first 3 are FP3 files. So I've got one there, and one there, and the bottom one is an FP1 file. So those FP3s are all exactly the same file. This just allows us to view the same file, the different parameters of the same file at the same time. Okay, so what I'm going to do, we'll go through what these parameters mean in a minute. So if you go up here, you'll see this area, it says time scale. we've got two different sections. We've got the high res section, which goes from 10 microseconds to 100 milliseconds. And what that means is each pixel on your screen is representing that amount of time. So if I just click this button here that says show from start, it's going from the beginning of the file, and it's 100 milliseconds per pixel. So as I move my mouse across, you can see that the as I hover over it, the time is moving along, and each pixel is represented by 100 milliseconds. These dashed lines here are minute boundaries. So if I hover over there, I can see that it says 12:43. If I hover over here, it now says 12:44. And that's just on my particular screen at 100 millisecond resolution. That's what it looks like. If I click 50 millisecond resolution, I've now effectively zoomed in, and you can see that this minute boundary is now bigger. The other way you can zoom in, so you can either change these up here, or you can use your arrow keys, your up and down arrows on your keyboard. So if you do up arrow, doesn't matter which one of these files you hover over, if you just do up arrow, you'll see that we've gone back to that 100 millisecond resolution. If I click down arrow, I've gone back to 50. You can see it changes up here. I go down again, and it's now on 20 milliseconds. I can keep going all the way down to 10 microseconds. So I'm just going to quickly check this chat a minute, make sure I'm not missing something. No, that's fine. So before we do anything else, so I'm just making sure I haven't missed anything before I move on. Yeah, I'll show you this first actually. So I'm just going to go up a couple of times again. Now the other way, so I've shown you how to zoom in on the time scale. The other thing that makes navigating a bit easier is if you want to move the section that you're looking at. So you can see my cursor is here. If I want to position where my cursor is on the left-hand side, so I basically want to move this to there. If I hover my cursor over and then use the right arrow key on my keyboard, that has now moved over to here. So it hasn't zoomed in, it hasn't zoomed out, it's just shifted the screen over. In the same way, if I want to shift this edge here to the right-hand side, then I put the cursor where I want it, where I want the right-hand edge, and I use the left arrow key, which basically says shift me over. So that's now positioned over this side. So they're just quick ways that you can move around. All of these navigation shortcuts and keys are in this navigation section. So you've got the navigation panel, and you've got all the F keys. We'll go through what some of these do in different sections, but this is kind of your go-to for your shortcuts. You also notice that when I hover my mouse up here, I get the menu coming up. Sometimes it usually works. If it doesn't work, you've got a menu button up here. You click that, it will bring it up, and click it to get rid of it again. But Nick's added this thing that basically means if you hover over there, it will show the menu. Other thing worth pointing out is when you hover over a control, so a button or anything that you can do anything with, this top bar up here gives you context sensitive help. So I hover over that, and it tells me what that button does. I move, and it tells me what that one does. I appreciate Zoom is sometimes a bit laggy, so it might be that I'm moving my cursor around and you're not seeing it immediately. If that's particularly bad and you're missing something, let us know, and I'll go over it a bit slower. Okay. So what else did I want to say? Yeah, okay. So another useful thing is this button here that says fit whole time range on screen. So if I click that, and now I'm going to close two of these files, two of these copies, because it's just going to clutter my screen and I just want to show you something. The quick way of doing that is you just click the file name once and it disappears. Click that one, disappears. So I've now got an FP3 and an FP1 file, just one of each open. And I've already clicked fit whole time range, and that's given me 30 minutes per pixel. And then I'm going to click show from start. So what this is going to show me is the whole file. So in this case, it's a short deployment of about 9 days. And down here, it shows me that it's 9 days. And this just gives you a quick overview of what your deployment looks like. We'll go through what these parameters mean, but the parameters that you're looking at, so the red ones mean that there's a file open associated with them. So we've got this one and this one. The bottom one says amplitude. Basically what you're seeing is the loudest sounds. There is a color key when you first open the software. We don't actually have one available after that point. It's not too important, and you'll quickly remember what it means. It's just, if you imagine you've got a chromatic scale from red to violet. Red represents the lowest frequencies that that can be displayed, and the violet represents the highest frequencies. And you're basically going from red, which is around 20 kilohertz, up to the violet end, which is sort of, I don't know, 180, maybe even 200 kilohertz. So you can see on this deployment, we've got these regularly separated sort of different colored sections. And as I hover over, I can see that they're sort of 12 or 13 hours apart. And I can know, I know what's actually happening here is those are tidal cycles. And this pod was deployed in very shallow water. So this, if you have a look at the top of the bottom file, you've got these little vertical dashes. Well, they're sometimes vertical, sometimes they're at other angles. What that's showing you is the angle that the pod was at that particular time. So when it's vertical, it means it was deployed properly and the hydrophone was pointing upwards. At these lower water times where it's basically bouncing around in the surf, the pod is horizontal or very near to horizontal. So that's telling me that at this point it isn't deployed properly and the noise profile has changed, which is why we're seeing a lot of these different frequency clicks. The top section I've got set to this trained species class. We'll go through more of this in a minute, but down here, these are color coded, and we've got these three things ticked here: MBHF, other cetacean, and sonar. I'll talk about this again, but MBHF we read as porpoise, and other cetacean we read as dolphin. It's not that easy to see on this scale, but there's a few little purple dashes around here. There's a lot of red, which is boat sonar, and there's a few dolphin detections in orange. So we can immediately see that we've got porpoise detections and we've got dolphin detections, which is great. If I now change the scale to 1 minute and then go show from start again, we can see this line here, which you could see in the other screen and in the other resolution view. This is a temperature scale. And we can see that it starts off pretty warm, about 24 degrees, and then it gradually drops down to about 15 degrees. So this is another indication that it's at the start, it's not in the water. And you can see here that those little dashes showing that the angle is flat, or it's inverted. At this point, it was deployed, and then the temperature starts dropping as the water cools the device down. So again, it gives you an indication of when the FPOD was correctly deployed. So at this point, I'm going to stop talking and just let you guys have a play with that. So if you just want to open your FP1 and FP3 file set, and then just have a play with the time scale, zooming in, moving around, and just see if you can familiarize yourself with some of those controls. We'll just give you a few minutes to have a play with that, and we'll answer any questions that you have on that while you're doing it. So Jeffrey's asked, where do you see the temperatures? So you only see the temperatures when you're in the low resolution view. So anything from 1 minute upwards, you'll get this line, and you can see it on the file below. It should be on all the files when it's set to low resolution. When it's set to high resolution, which is 100 milliseconds and below, you don't get those details shown, and you don't get the angle indicator shown either. Ah, I see. Yeah, so Jeffrey's asked, how do you know it? So as you hover your mouse on the line, so you get the point of your cursor, and that will tell you at that point what the temperature is. We'll briefly cover exporting data later, and but that actually allows you to export precisely what the temperature was at that moment. But basically you're getting it from just hovering over. So this is just a quick overview. It's not data that you're necessarily going to be making note of. It's just to give you a good idea of what your deployment looks like. Okay, so Mariana's asked, how does the angle affect data collection? In itself, the angle doesn't. There's various things you can do. So when you set up your FPOD, it comes with default settings already. One of those default settings is to not record data if the hydrophone is lower than the lid. So that's the lid and that's the hydrophone. That would record data. That wouldn't. That's basically to save power, so that it's not recording data when it's not deployed correctly. It might be that you have a situation where you want to attach your FPOD to something and you might actually want to point it downwards. In those situations, you can change the settings so that it's always on. But in itself, the angle doesn't. It just basically tells you that it's probably not deployed correctly, because normally a pod is buoyant, so it's going to be pointing upwards, and even in a fast tidal stream, it will lean over, but it's not going to be horizontal. Okay, Jessica's asked, what does the green line represent? Where am I looking at? Oh, green line. Okay, I think that actually that's not click rate, is it, Nick? You remember what the green line means?
That's the pod. When it gets very noisy, the pod raises the threshold for recording very short clicks in order to leave a lot of them out. And that's telling you what threshold it's running at. So actually in this period, which as Dan explained is the pod's lying flat, there's a lot of sand washing over it. So this is effectively sediment transport noise. And the threshold is rising to keep the number of clicks recorded down below an absolute maximum of 16K. Yeah, so it's called the operational threshold. And when you export the settings for every minute, you get the temperature of that minute, the angle for that minute, and this thing, the operational threshold for that minute. So you've got access to all this data if you ever need it.
Great, thanks, Nick. So yeah, just going to answer a few other questions here. So yeah, Mariana, if your pod has just come with the settings that we supplied it with, then it won't record click data when it's upside down. It won't record click data when it's horizontal, or if the hydrophone is below the lid, then it won't record data, but you can change that if you need to. Jason asking, does violet mean high frequencies are present and red means high frequencies are not? So it's a scale. You've got red at the red end of the spectrum is representing the lower frequencies, say 200, say around 20 kilohertz, and the violet at the other end is around 180 or 200 kilohertz, and all other frequencies in between are represented by the colors of the spectrum. So I think green is, say, 70 kilohertz, something like that. But yeah, it's just basically a spectrum of clicks. And in that particular view, it was showing you which frequencies are representing the loudest clicks. So it's basically a stacked bar chart when you look at it in the low resolution view. Anne-Marie saying, the black line in the F1 is amplitude. It's kind of, just look at what we're there. So if you mean black line down the bottom here, so these little peaks, this is the click rate. So it's basically telling you how many clicks are being recorded. And you can see in these noisy periods where the pod is actually not deployed because it's in very shallow water and has been knocked around in the surf, the click rate has gone up a lot, and that's the sound of the pod and sand. But basically it's the sound of sand moving around in the surf. So yeah, and these colors, like we said, representing the frequency of those, or the relative strength of different frequencies. So yeah, there's a lot of different concepts going on here that we're trying to represent in colors and graphics. Okay, right, I think that's probably enough time to play around with that, so we'll move on. Just minimizing the chat screen so I can see what I'm doing. Right, so let's have a look at the parameters. So in this section here where it says parameters, we've got each one. So obviously I've only got two files open. I've got my FP3 and the FP1 file. So these won't apply because I don't have a file associated with them, but it's the same drop-down list for all of them. We've just given you these defaults. So we'll just quickly go through what they mean. I'm going to switch it to 100 millisecond view. And don't worry about what I'm doing right now. We'll come back to that in a minute. So this one at the top that says frequencies. Frequency is the first one. That then changes the y-axis to represent frequency. If I click the refresh button, actually it would help if I did it on a file that was open. So frequency on F2, so that's file 2, I click refresh. So now this one has changed. And these, if I zoom in a bit, it will make a bit more sense because obviously it compresses everything. So I'm now seeing the frequency of the clicks. So each one of these points on this graph represents a click, and it's joined up to show you that the software has linked these into a train. So that's when you ran the FP3 process, the train detection process, it then found that these clicks were in a train. And there's a lot of different parameters that it uses to come to that conclusion. We won't go through all of those now. There's about 70 of them, I think. And once it's got its trains, it then goes through the trains and classifies them as one of these categories down here. So where it says species, obviously boat sonar isn't a species as such, but as far as the classification system is concerned, it is. And we have MBHF, as I mentioned before, which we read as porpoise. There are exceptions to this, which is why we don't call it porpoise. The MBHF stands for narrowband high frequency, which are mostly porpoises, and everything else we just lump into the category of other cetacean, which generally we read as dolphins, so other species, anything that isn't a porpoise. Then we have boat sonar, and we have this one that we haven't got ticked currently, which is unclassified. So the software knows it's found a train of clicks, but it doesn't know what it is. But it still recognizes it as a train of clicks, but it doesn't conform to enough of the parameters that would allow it to classify it as one of these other three. So that's what that means. So we've got frequency, amplitude, which we talked about before. If I click that, that's actually what this bottom one is showing. So that just shows you on a scale that we call SPL, which stands for sound pressure level. So that's basically the strength of the signal as it arrives at the detector. So the detector obviously only knows how loud a click is at the point it detects it. It doesn't know if it's a loud click from a long way off or it's a very quiet click that's very close to it. So it records the sound pressure level as it detects it. We have this other one which is very useful called clicks per second. It looks slightly different depending which view, whether it's on the FP3 or the FP1. So I click refresh, I've set them both to clicks per second. You can see here that I've got these straight lines. So again, because it's joined up the clicks into trains. And down here, you can see the individual dots. So the clicks per second is, as it says, how many clicks per second. So the higher the number, the faster the source is clicking. You can see the one that we're looking at here is pretty much a dead straight line. We'll talk about this a bit later, but that's a real giveaway that what we're looking at is boat sonar. But we will talk about that more shortly. I'm just going to go through the kind of physical parameters. So we've done frequency, amplitude, clicks per second. We then got this one here called num_n of cycles. So what that means is the number of cycles, and by cycle I mean a sine wave. So a wave that looks like that. Yeah. So up, down. That's one cycle. That's one complete sine wave. And number of cycles is telling you how many of these cycles each click contains. This is another thing that's actually really helpful for telling us what it is that we're looking at. So if I refresh this, we can see again on the y-axis, I'm getting an echo here. I think someone, is it Olive? You got your mic on? Thank you, great. Yeah, so this is all it's showing you is how many, for each one of these clicks, how many cycles each click contains. Inter-click interval is kind of the inverse of clicks per second. So this is actually a kind of truer representation of what's physically going on, because all it's telling you is the gap in time between the clicks. So the clicks per second is kind of extrapolating one single gap between clicks and then saying, well, if that gap persisted for a whole second, this is how many clicks we would get in a second. Whereas the inter-click interval is just showing you literally how far they are apart. You can see here, this is dead flat like it was with the clicks per second. I'm not going to cover all of this stuff now because it's probably going to be covered in another course anyway. What I will do is talk about these three. So this one that says train Q class. In fact, I'm just going to switch this bottom one back to amplitude. So train Q class means the quality of the train. And on this over here on the left, you've got high, moderate, and low. And high quality is obviously the best one. And this has been colored in red. We've then got some moderate quality, and we don't have low ticked. But if I click low, we might see some. No, we don't. But yeah, so it's just telling you what the software thinks, how good a quality these click trains are. That's what it's showing you there. The one below that, which is train species class, which we actually looked at when we looked at the low resolution view. So if I refresh that again, it's showing that it's red. And if we look down here, the train species class of red is boat sonar. So as we said before, there's a few telltale signs that this is boat sonar, and the software is confirming that for us. Lastly, we have a thing called MBHF index. So this is a composite value. It's not one physical thing. It's various different values that have been added together in different proportions. And MBHF index, which is basically how porpoise-like is the click. And the higher the number, the more porpoise-like it is. So over 3 is porpoise-like. Below 3, I think 3 and below is less porpoise-like. So probably dolphins. So that's what the main parameters mean. I'll just refer to my notes, make sure I haven't missed anything. Yeah. Okay. One thing which is kind of to do with the navigation as well, but I'm going to mention it here. So if I go back to show from start, up here you've got this thing that says seek in file, and you've got all the files that could be open. It should actually have grayed out 3 and 4, but I'll ignore that. So it's saying that it wants to seek in file 2. Generally, you always want it to seek in an FP3 file, and we know from the files page that our file 2 is an FP3 file, so that's good. When we click show next screen, and the shortcut for that is F1, with these things ticked, so we're going to see any MVHF, any other cetacean, and any boat sonar, and we're going to try and find any of those in file 2 in F3, because that's where the trains that have these classifications are. So if I press F1, which is the same as clicking show next screen, it will take me to the first train that it's found in the file that meets these criteria. So it's any of those. As it happens, it's gone to boat sonar. So that's what that's showing us. Right, I think.
Could you go to a dolphin train?
Yeah, sure. I was going to go through the features of the different trains in a section after this, and just let people have a little play with those different parameters, just so I'm not covering too much in one section, and people have got to remember what I've been talking about. So if I, as Nick said, if I untick MBHF and I untick boat sonar, and then I click F1, that will take me to the first other cetacean, and we'll talk about that more in a minute. So yeah, if everyone wants to just have a go at playing with those things that we've just covered, and then we'll talk about some of these other features in more detail. As again, we'll answer any questions now. Okay, so Jeffrey's asked, what are the color codes in the upper panel? Seems to be a mix of colors. So it depends on the parameter that you've selected as to what those colors are showing. In the view that I'm looking at here, I've got amplitude set for both. This is a bit confusing, if it isn't already confusing enough. The colors down the bottom are showing you frequencies. I know it's set to amplitude, but it's showing the colors are representing frequency of those clicks, and the height is showing you the amplitude. In the upper panel for amplitude, where I've got the FP3 file selected, these colors are actually random. They're just identifying individual trains. So sometimes trains can overlap, and it can be hard to tell where one train starts and another train ends. And that's the only reason we have these colors here. You can change that if you go to files and filter. Oh no, if you go to display, and you've got this option down here where it says color clicks by train number. By default, that's selected. If I unselect that and then click refresh, it's now back to its kind of normal view, which is to show the frequency the same as it does below. So what you're seeing up here is a filtered view of what you've got down the bottom. In other views, the colors can represent other things. So like the Q class, the colors are the red, yellow, and green. In the species view, then we're looking at purple, orange, and red to represent different species. So yeah, I realize that we use colors for all sorts of different things. It can be quite confusing. Roberta's asking, what are the most useful parameters for a quick overview? So when we looked at the kind of the low resolution view, where we looked at the whole file in one go, and all I selected for that was I just had one copy of the FP3 and one copy of the FP1. And the FP3 I had species class selected, and the FP1 I had amplitude or frequency. Either would do for that. I think it was amplitude actually. Yeah, I mean that's just one way that you can look at the file in one go. There might be other parameters that you would find more useful. It's more just having a play and seeing what it looks like. When we look at the high resolution view, then we have a lot more options that are useful. So we'll come on to that in a minute. We'll reopen the files with more copies again and show you some of those in more detail. So yeah, Mariana, we just discussed that about how the color coding shows you multiple trains. How many FP3 files are worth selecting at one time? Partly it depends on your screen resolution. If you've got a big screen, then with high resolution, then you can potentially have 6 copies. I quite often have 2 FP1 files and 4 FP3 files open at the same time. On my screen that works fine, but if you're looking at on quite a smaller laptop screen, a 14-inch screen or something, then that might be too much for the page. Does this color help? Yeah, I guess you're referring to the overlapping train colors again. Yeah. Okay. Right. So what we'll do now, if everyone's happy for me to move on, is I'll go up to the files page again, and I'm going to click. I think one FP1 and 3 FP3s will do for now. I don't want to put too much on the screen and cause anyone a problem with that. So I'm just double clicking that one again, and I forgot I did that. Right, close files first, close all files, then open a file set. then double click one of the files in the set, and I've now got my 3 FP3s and my one FP1 file open again. I'm going to change these to the fourth file, which is one of the FP3s. I'm going to change to amplitude. I'm going to change F3 to well, let's do species class and then clicks per second. And I'm going to change the FP1 file to clicks per second as well. Okay, I'm now going to go to show from start. And you notice that the file 2 is selected in the seeking file, which is this one. Doesn't matter which one of the FP3s, as long as I've got that set to an FP3 is all that matters there. Okay, so what we'll have a look at first is a dolphin train. So a useful thing you can do, you can save time points. So a particular point in the file that you want to come back to, and I've saved one. So all you do to do that is you right click on where you want to save it, and you go down to save time points to file, and it'll save that into the FP3 file. So I've already got one. I'm going to click this. So it's actually the thing I've saved is in the middle. This is, so you can see here in the species class, it's all orange. So the software is telling us that these are all dolphin click trains. I've got the amplitude at the top of the specific clicks in the train. I've got this is actually, yeah, anyway, the species class, and then I've got the clicks per second. And I've also got clicks per second at the bottom in the FP1 file. And I'm going to zoom in. Well, another way you can zoom in, so you can use the down arrow like we discussed. You can also drag. So if I hold down my left mouse button and then drag over, you can see the line at the top, and then let go, and it's zoomed into that section that I highlighted. And I'm just going to move the screen over. So I'm going to hold my cursor here and left arrow key on the keyboard. So I'm now looking at this particular click train that I'm interested in. So a feature of cetacean click trains is the click rate. So we can see clicks here in the FP1 file that haven't all been classified by the software. They haven't all been found to be within a click train. But we can see that there's a bit of a sort of profile to this. It sort of moves up and down. You can see that they're kind of joined. It isn't just random noise that's been joined up. You can see that there's some kind of form to this. This kind of undulating click rate is the kind of thing that you see. What you see in cetacean click trains. So in this case, a dolphin. When you look at boat sonar, you don't see that. You see a very flat train, very flat click rate. The other thing you'll see here is not particularly obvious, but in the amplitude scale, you can see that there's a bit of a kind of envelope, we would call it. So it starts off low, the amplitude goes up, goes down, goes up again, but it moves. They're not just random points on the scale. There is a sort of things flow into each other. And what's happening there is as the animal swims, so as the animal's moving up and down and vaguely pointing towards the detector, their narrow beam of clicks is sweeping over the detector. So it's coming in, and at the edge of the beam, the amplitude is less than it is in the center. So that beam sweeps over the detector, and that's what we're seeing here. We're seeing, maybe this is towards the center of the beam, and this is towards the edge of it. So again, that gives us a good indication of what we're looking at. I'm just going to show you another way of navigating. So this underneath in the parameters, you've got this thing here that says set. No, sorry. What am I talking about? Underneath train filters, we've got the marked trains included. So what you can do, you can as well as set an individual time point, you can also mark any number of trains so that you can come back to them or just look at those trains without looking at anything else. So I've already marked in my copy of the file, yours doesn't have this, but this is just so that I could go to something useful. I've marked a porpoise train and a boat sonar train. So I did just have other cetacean ticked. I've now reticked MBHF and boat sonar. And what I'm going to do is go again, show from start, and then the marked trains included. If I click those words, it changes. And I click it again, and I now got marked trains only. And then I'm going to go to show next screen. And then I'm going to untick marked trains only because I actually want to see all of it. That was just my way of getting to this area. I'm going to click refresh. Now, looking at this, you can see there is a bit of a straight line here, although there is definitely some kind of profile going on with the amplitude. And if you remember, we use F5 to scale up. So actually, possibly I didn't even mention this, so apologies. I should have mentioned this earlier. To change the scale of the graphs, because obviously it's sometimes you're trying to look at something that's very loud on the same graph, you're trying to look at something that's very quiet. So F5, so it only affects the view that you're hovering over, so it's only affecting this one. I press F5 several times and it makes it go up. F6 makes it go back the other way. And if you go to the navigation pane, it tells you this. So we've got F5, F6, Y scale up and down. If I now zoom out, so I'm going to do up arrow, and then up arrow again, and then I'm going to move using the right arrow key, so I've shifted it over. Boat sonar is really easy to see when you look at a bigger time scale. If you look at really zoomed in, very high resolution, you can't always see it. But if you look at the files, generally, the more you zoom out, the clearer it is to see. And you can see we've got this dead straight line in the click rate. And that is absolutely a sign that this is boat sonar. And we can see in the species class that it's colored in red, and red is boat sonar. So I have no problem in agreeing with the software that that's what it's looking at. I'm going to go back to this thing here that says mark trains included, because I also, actually, let me just refresh this. So these will all disappear. And I'm going to go to show next screen. So this is just so that I could get to a particular place in the file that I wanted to show you, which is this one. And then I'm going to go mark trains, mark trains included. That's basically show me everything is what that means. And then click refresh again. So I only marked that first one. When you mark a train, so if I go right click and then mark this train, which is what I did earlier, you can see that the lines are dotted. That's just to tell you that it's been marked. That's all that's showing you. And you can see here, species class is purple. Coincidentally, it's the same shade of purple that the frequency is indicating. So these aren't actually exactly the same color, but the purple up here and the purple down here is telling you that the frequency is around about 120 kilohertz or thereabouts. And again, you can see that the amplitude, there is a little bit of a profile. We don't have particularly good quality porpoise data in this file. It was actually a deployment in Mousel, where Chelonia is based, just off the harbour. So it's not the best deployment, but we do get a couple of different species, and we see some boat sonar. Again, if you look down here, I'm going to scale this graph up using F5 again. You can see that we've got this undulating click rate. So this again is telling us that this is a cetacean, and the software has classified it correctly. We're looking at species class in this one, and purple is porpoise, and indeed it's coloured it purple. So that's yeah, we're quite happy that is indeed a porpoise. So I'm just checking if I've missed any messages. No. Let's see if I need to tell you anything else. Yeah, there's also a shortcut for refreshing. So rather than go up there and press refresh, if you press F3, it does the same thing. And one other kind of side note is you can save the view that you're looking at. So obviously it took a little while to open the right number of files, go through, select all the different parameters, select the filters. If we want to, we can save this exact view and this point in the file so that we can come back to it and it will look exactly the same. And the way we do that, there's two ways we can do it actually. One is to right click. Oh gosh, what happened there? Anyway, right, I think I right clicked and dragged at the same time and that upset the software, so I'll try not to do that again. If you look down here, when you right click, there's an option to save comment file. So a comment file is a file that has an extension FPF. So I'm just going to call this demo. Demo corpus example. And I'm going to save it there. So just to show that this does actually work, I'm going to close all my files. And then I'm going to go to filters and files. And over here, we have this thing, we've got save FPF. That's actually exactly the same as right clicking, going to that option. The save comment file that's the same thing as clicking save FPF. And I'm going to click load FPF. Now I'm going to double click the one I've just created. It says, do you wish to reopen the files? So I'm going to click yes. So now I'm going to select the files that this FPF applies to, double click that, and it's saying, do I want to return to the same saved point? And I'm going to say, yes, I do. And there it's brought me back. I didn't actually refresh the page in between, and I know it did retain that view, but it had actually closed the files. So this is opening it again from afresh. Sorry, Marianne, I don't quite understand your question. Okay, well, while we look at that, if you all just want to have a go at what we've just looked at and see if you can find some porpoise trains and some dolphin trains and some boat sonar trains, and just have a play with that for a few minutes, and we'll answer any questions that you have while we're doing that. What we'll do after we've had a go at this for a few minutes is I'm just going to take a 5-minute break. I'll stay on for a few minutes and then go off for 5 minutes. And obviously, if you guys want to carry on looking at this or take a break, well, that's absolutely fine. So Luan has asked about recommended parameters when verifying the species classification from the software. So we're not going to cover evaluating false positives in this course. We will cover that in one of the upcoming training courses. This was just to sort of show how you can view it and what the software is doing. I think amplitude, species class you can view, or you can just use the filters to show a particular species. But for me, amplitude and clicks per second and number of cycles per click are the three things that I use when I'm verifying whether the software's got it right. But yeah, we will go into that in more detail in a future course. Right, I'm just going to take 5 minutes. So GMT, we're on 12 minutes past 6. So I'll be back here in 5 minutes, about 16 or 17 minutes past, if that's okay with everyone. Right, hi everyone. I'll just give people a minute or so to make sure everyone's back. So yeah, I'll assume there's no other questions on what we've just been looking at. Okay. Right. Okay, so oh, actually, I think there's still a couple of people away. Okay, I'll get started. Right, so next thing we're going to look at is the clock. So in the user manual for the FPOD, it shows you how you can set the clock to your local time. We're not going to cover that here, as that's kind of hardware, and we're just looking at the software today. But if you realise afterwards that the clock hasn't been set to the local time of your deployment, you can change that in the FP files afterwards. So we're just going to quickly look at that, as that's something that people often want to do. Right. So again, I'm going to close two copies, just so, because all I need is one copy of the FP3 file and one copy of the FP1 file. Because what we're going to do is change the clock in both. We want to change it in both files, otherwise they'll be out of line. So we want to simultaneously change the clock in the FP3 file and the FP1 file. I'm going to set this to 1 minute resolution, so that's into low res, but at the very beginning of it. Doesn't really matter what I click it to. I'm going to change these to amplitude, just for the sake of it. And then I'm going to click show from start. So again, we have the low resolution view that we talked about earlier. Down the bottom here, this tells you the date. So we've got year, month, day, and then hour and minute. So it's showing you, this is telling you the first minute that this deployment started. Well, not this deployment, the first minute that the device was switched on. But what it's showing you is only showing you the first minute of when it was switched on, because I click show from start. If I position my cursor there and then right arrow, it's now showing from that point, so you can see it's moved on a bit. But we want to know when this deployment, when this device was actually switched on. So let's say that the correct time zone was GMT or UTC, however you want to call it, +2 hours. So what we do, we go up to the menu, which, like I said before, you can get from clicking the menu button or just hovering your cursor up here. We go to the read SD. So this is a little bit confusing because it says here CPOD only. For those of you who don't know, the CPOD was the previous generation of devices that we made, which works a bit differently. So same principles, but it does work a bit differently. And we actually use this field here to set what we believe is the true start time. So I'm going to change this to year 2022, month 6. Oops, sorry, 6. There we go. 12th day, and we want +2. So let's change that to 14. The minutes are the same. 42. Okay, so that's the true start time that we want this deployment to have. And the next thing I need to do is go to filters and files, and then go down here, and there's a button that says change start time. So I'm going to click that. And if you notice up in the top up here, it will, up here, it tells you hovering over that button what that's going to do. So it takes the start time from the read SD page and applies it to all open files. So you need to make sure that the files that you have open, first of all, that you have the files set. So you've got an FP1 and an FP3 for that particular deployment, and no other files open. So click change start, and it says start time will be changed. And now if I click show from start, exactly the same data, but it now says 1442. So we've changed that in both. Both files are synchronized, so that's all good. Next thing we're going to look at, again in this same view, is how we crop the files. What we aren't interested in is when the pod wasn't deployed. So before it goes in the water, as in this case, there was a few minutes at the beginning. These could be hours, weeks, even a month before, where the device potentially could have been on but not deployed. We want to crop that because we're not interested in what ultrasound clicks have been detected on the deck of a boat or in someone's office. So rather than save that data and use up space and energy, we're going to crop those off. So obviously this is only a few minutes, doesn't make a huge difference, but just as an example. Now, where I hover my cursor, where the point of the cursor is, that's where it's going to start. So I'm going to hover it there because I can see that it was warm and the device was inverted. So this is basically telling me at that point where it suddenly goes vertical, that's when it hits the water. So I'm going to right click, and then I'm going to go to set selection start. So that's done. And then get the menu up, and in files down the bottom here, I've got create new cropped copies of all open files. So I'm going to click create, and it's telling me how many minutes from each file have been copied over. So it's 13,631. The number doesn't matter, it just confirms to you that it's done. Now what I'm going to do is close all the files. I'm just going to change that to 1 so that I don't have to close them again. Click open a file set, and you see now where I had my sample files open, I've now got this other one that says part, and then the length of it, 9 days, 11 hours, and 11 minutes. And I'm going to double click that one. And then I'm going to click show from start. And you can now see that that first few minutes where it was out of the water and inverted has been removed. So we've just got those that cropped copy left. The other thing you can do when you're cropping a file, I didn't do it on this one because this is actually there wasn't a period at the end of the file where it wasn't deployed, but obviously in your examples there probably will be. If I click the end button, so just the key on your keyboard that says end, it will take you to the very end of the file. And then just to make sure I'm looking at the end, so where my mouse is, the cursor is, if I press the right arrow key, so I can see here that there isn't anything to crop off the end. If there was, before I clicked the create copies, so after I'd done the select or set selection start, I would have gone to the end, and then I would have clicked set selection end, which is this one here. And then after I'd done both of those, I would then have gone in and clicked create copies, and that would have given me just a single cropped file, which is what we're looking at here. So let's look at that again. And just a word about files. So once you've created your FP1 file and you're happy that the deployment has worked in terms of the device has functioned correctly, there's no need to retain those data files that were on the SD card. So you want the FP1 files, but you don't need those data files that are on the SD card once you've got your FP1 file. And also, once you've cropped your FP1 and your FP3, there's no need to keep the uncropped version. It's best to delete them because apart from anything else, you don't want duplicates in your data sets. And also, when you save your FP1 files. So if you've got a project where you have many deployments, it's best to save those files, the FP1s and the FP3s, in the same directory. So what that means is if you want to reprocess them or export data or do anything to them as a batch, then you've got them all in the same place, and it just makes life a lot easier. Okay, so we're just going to say if you all want to have a go at that, so have a go at changing the time on your files and cropping. And yeah, Mariana's asked what does the angle bar mean when it's red? So that actually means that it's not logging. So usually when these angles that you can see here, I'm pretty sure this pod has been set up to record data. Well, it's been set up to record data at all angles, which is why even when it wasn't deployed properly, as in it was inverted, we're still seeing data. If that wasn't the case, when it's not recording, these little dashes showing the angle would be red, and that tells you that it's not recording data at that point. When I say data, I mean clicks. So it's still logging time. I think it's still logging temperature and it's still logging temperature and angle, but it's not recording clicks, which is the thing that uses up memory and power. So recording the temperature every minute and recording the angle every minute uses very little power from the battery. So that's why it carries on recording that, even if it's set to not record at that angle. Okay, Jessica asking, how do we move to the end of the file so quickly? So all I did was hover my mouse, so obviously focus on the software. But once your mouse is over the data, all I did was click the end key. So that isn't a shortcut. That isn't a button on the software. That's the key on your Windows keyboard that has the word end on it. On mine, I have to do function page down. Everyone's keyboards are different, but somewhere on your keyboard there'll be the facility to click a button that says end. And if you do that, then it takes you to the very end of the file. Okay. Okay, so Jeffrey asking about when you change the date and time, does it change it in both files? So what it does when you enter that date, so as we were just saying on the read SD page, we enter the date that we want to start this file at. So this is the new time for the new switch on time. It will change to that. It will change the files to that date of any files that you have open. So you always want to change the FP1 and the FP3 at the same time. So you need to have at least one. It doesn't matter if you've got 3 copies of the FP3 or 1 copy, as long as you've got at least 1 copy of each of those files open and no other files, then it will change those at the same time. And you want to make sure, like I said, that you've got 1 FP1 and 1 FP3 at least open. But if you had another deployment open that you were looking at, so it might be that one deployment ends, another deployment starts, and you were looking at both at the same time, which you could do. You have to make sure that you close the files that you're not changing the time on, because otherwise it will change the start time to all of them, and then you'd have your other deployment looking like it started at exactly the same time as the previous deployment. So you don't want that mess, basically. So yeah, whenever you do any file changing thing, just be really aware of what files you've got open, and you can check that by going to the files page, and then you look down here and it tells you which file is which. And you can see clearly that this is a file set of an FP3 and an FP1. Okay.
It's just another follow-up from Jeffrey, Dan.
Oh yeah, thank you. No, you don't need to rerun the kernel classifier. So all you're doing is changing the start date time information on the files. It doesn't affect the data in any other way at all. It doesn't affect the clicks on the trains or anything. It's literally just telling telling the software what that first minute is, so that it can label it correctly. So you said it, Mariana asking, is there any way to change the time zones or only manually in Excel files? So when you say the time zones, so the only time that's saved in the files in the FP1 and the FP3 is what we've just looked at. So if you want to change the time zone, then you need to do what I've just done, which is find out when the start of the file is, which is down here. So you've gone show from start, and it shows you the start minute, and then you go into the read SD and you change the date and the time to what the true start time was for that time zone. You can obviously, if when you set up the FPOD to start with, then you can set the actual time at that point. And then you won't have to do this because it will already be running at the correct start time anyway, in the right time zone.
Dan,
yeah,
it might just be worth saying that on the filters and files page, you can move the start time by like any whole number of minutes. So for a sort of 3-hour time zone change, you add or subtract 180 minutes. Yeah, so that's over on the right at the bottom there. Add M to start.
Okay. Okay. Add M to start. Right. Okay. And when you click add M to start, that then does the same as the change start time. So that actually changes the file at that point.
Yeah.
Yeah. Okay. Yeah. Yeah. No, that's, yeah, I've never done that actually. So that's useful to know.
If you've got a really big discrepancy, it's kind of easier to use the method you described. And somebody in the chat had a pod with a clock that stopped working. So their file starts at the end of 1899. So your method is going to be a lot easier for them.
Yeah, if you ever have that problem where, as far as you're concerned, you've set the time right, well, they'll come from us with the time set to GMT or UTC. But you run your deployment, and then the clock, as Nick says that it started in 1899. What's happened is the battery, there's a tiny little disk battery, like the sort of thing you get in a calculator, that's part of the circuit board. That battery should last the lifetime of the pod. It should last at least 10 years. But it's possible that there's, if there's a fault with the battery where it becomes somehow disconnected due to a heavy shock, that it then won't retain the clock time that's been set to it. And as Nick said, you can use this method to do that. But yeah, it should hopefully work. Right. So we're just going to very quickly look at some basic analysis and exporting your results. So we will cover exporting exporting data in a future course in a lot more detail, but we're just going to oh, sorry, Jeffrey's saying I've been file set and tried closing 2 files from info, but the program won't let me close file 4, only files 1, 2, and 3. Okay, I've not had that happen, so it should just be a matter of just clicking on the file name, and it should do that. Maybe we'll come back to that at the end if we have time. Yeah, any questions you have that we can't get to now, we can answer separately after the session. And if you want to email anything, just do that, and we'll get back to you as soon as we can. Right, so we're just going to look at analysis. So it doesn't matter how many copies of these files you've got open. You click the analysis page, and then you want to make sure that this file thing is set to one of the FP3s, which it is, and then I click Analyze. And what this is going to do is give me a very quick overview of the files. So it's drawn some graphs for me, and it's given me some summaries of data. So it's given me a kind of frequency spectrum of the whole deployment. So yeah, just to say, this shows you everything that you're seeing in the analysis page is for the whole deployment, not just the section that you happen to be looking at when you clicked it. So down here we've got sort of clicks per second in 2 different ranges, so sort of low rate and high rates. We've got a kind of amplitude spectrum, we've got frequency spectrum, we've got a number of clicks in a train, a sort of distribution graph showing you details of that. Over on this side, we've got average number of clicks per hour, got the total clicks, average clicks per day. So one of the metrics that we use that's very commonly used is DPM, which stands for detection positive minutes. So that's telling you that in a given minute there has been a detection for what you've got selected. So if I want to know, if I've got, say, MBHF selected, then a DPM, a detection positive minute, it doesn't matter whether there was 1 porpoise train in that minute or 100, it would still count as detection positive. It's either a 1 or a 0. And we can use that DPM, that detection positive minutes per day, is quite a common thing that people want to look at, which is going to tell them how many minutes in that day have a particular species been recorded. The only down point of that is if you've got a very active site, then you could potentially max out that parameter. So there's 1,440 minutes in a day. If you're getting close to a third of that, then you probably want to use something else. Again, we'll cover this in a lot more detail in a future course. Another thing to show you is if I go back to show from start, and if I just zoom out a bit, so I've just used the up arrow again. Oh, actually, that's too far. Down arrow. And then over on this side, I'm going to uncheck MBHF and uncheck boat sonar. I've just got other citation. I'm going to click refresh just so we can see. Yep, so we've got, these are the other citation clicks. And so I'm just looking at a little window of the whole deployment. Up here, I've got a button that says graph. When I click that, it's actually showing me the frequencies that make up each of those views. So the top one is obviously the FP3, the lower one is the FP1. So this is telling me that the frequency spectrum of those dolphin detections looks like this. It's quite low, but you know that's not uncommon. But we can see that the frequency spectrum of all the clicks in that time period are weighted much lower. So that peak is around 18, 19 kilohertz. So the vast majority of clicks for that period are at this much lower frequency compared with the clicks that were detected and identified as belonging to dolphin trains. These are probably mostly boat sonar, but there'll be sediment transport noise in that as well. So where the particles of sediment are knocking against each other they then produce high frequency clicks. And actually the frequency of those clicks that comes on the sediment is kind of determined by the size of the sediment. So yeah, different substrates in different in heavy sea conditions will produce different frequency spectra. And just very quickly to show you this display tab here, we'll go into that. Not going to go through all these different ones, but you can see down here, so a bit like we had on the parameters, we've got parameters of what we want to graph. So file 2 and file 1 are both set to kilohertz. You can set those to all sorts of other things. A lot of these won't really work very well because we've got a very few clicks that we're looking at. And also remember that all it's going to graph is the window that you're viewing. So unlike the analysis page that will graph and show you summaries for the entire deployment, when you click that graph button, it's just going to show you the window that you've zoomed to. And these are the different things you can graph. So things like DL patterns, number of clicks. So DL being the daily cycle. So over that period, it would show you the average daily activity cycle. So it might be that on average you have a lot more activity, I don't know, say 9 o'clock in the evening and very little activity in the middle of the day. Again, that works better when you've got a lot more clicks, because obviously if you're trying to take an average of very few detections or very few trains, then it's going to be a lot less meaningful than if you've got a longer period with a lot more clicks that the software can then sum for those. So that's really just showing you some of the options that are available. But again, these will be covered in greater detail in a future course. Checking if there's any questions I need to answer. So Marianne has asked a question that Nick has answered. Yeah, if you just want to have a quick go at that. So that's kind of the end of me talking. Oh no, it isn't. No, there's something else I haven't mentioned. No, sorry, false alarm. I still have more talking to do. So again, as I keep saying, it will be covered in another course. If you want to export data, so this is say you want to export it to a database or into R or into Excel, you can do that. So in the export tab, so any filters that you've got set, so all these filters here, and there's a whole, as we've briefly looked at this page, there's all sorts of other filters that you could apply. Mostly you don't need to, but there are circumstances where you might. And again, we can talk about that in more detail another time. All of those filters will apply to what you're going to export here. So this detections and environments is a kind of a quick way of exporting lots of different common things that people want to look at. I'm going to just select DPM, and down here I've got other cetaceans selected, so the other things aren't selected, the other species aren't selected, and I've got high and moderate quality. I didn't actually mention there's this other thing that says high species confidence only. Generally you want to have that ticked. It might be that the classifier gets things, it does an extremely good job and you can untick it and get some ones with lower species confidence, but general rule, leave that ticked. So what we're going to do, we're going to export detection positive minutes for other cetaceans, and we want it per day. So detection positive minutes per day, and this will apply to the whole deployment, not just the window that we're looking at, but everything. And I'm going to click export from batch of files. Now we don't have a batch, we've just got one file we want to do. That was the previous one, the uncropped one, which I would delete in normally. So we're going to click the crop one and click, open. So what it's done is paste it into the results. So you can either copy that out, or if you could go into export again, what I should have done actually was click text file. Just makes it a bit easier to see what you've got. So I'm going to click, just repeat that again, export batch. double click on that FP3 file. It'll only ever give you the option to select an FP3 file when you do an export, and it's telling me where it's saved it. So I'm going to go to that location on my computer, which is in here, FP3 files, and it's this one. So it's the one that ends in .txt because it's just a text file. And what I'm going to do is, actually, I think the headers are selected confusingly. I'm not quite sure why it had include headers. Normally that would be unticked. So I'm actually going to, sorry, going around in circles here. So I'm going to go to, so I've got include headers unticked, export from batch, just doing it for the third time. I'm going to change my screen share so you can see what I'm doing. Share, so this is now my whole screen, not just the software. I'm going to go to where I've saved that file, which is here, this text file. And I'm just going to select everything and copy it. Then I'm going to open Excel and paste it in. I've just made all the columns the right width. And you can see down here, this chunk end, that tells you the end point of that particular block of time, which is a day, because we wanted to save DPM per day. And for each one, it gives you a DPM, which we filtered for elicitation of how many detection positive minutes there were in that day. So we can see immediately that we've got some days have a lot more detections than others, and some have none at all. So I can just graph that really quickly. So there we go. Very quickly graphs my detection positive minutes per day across the deployment. So that's my whole deployment, which I think is only 9 days long or 10 days long, but it just shows me the dolphin activity across that deployment. So yeah, if you just want to have a quick go at that, and we'll take any questions on that, and also any questions on anything else that you have about the course. So I have now finished going through everything that I wanted to talk about. Obviously that export, you could export and import it into Access or R or whatever software you want to use. So yeah, if you just want to have a go at that and fire any questions over to us, that would be great. So yeah, we've got about 10 minutes left until we finish. Okay, so Robert asking what were the other columns in the text file? So in that DPM view, the first column was file, so feel free to have a go at this yourself. So we have file and then site code, which would be information that you would have put in when you generated the FP1 file. The pod number it picks up automatically, which is the serial number of the pod. The chunk end, as we said, is the end minute of that day. So it's only day because we exported DPM per day. If the chunk was not a day, then it would be the last minute of whatever chunk we summed. The minute is the minute number, which generally doesn't mean much for most people, but occasionally can be useful. We've then got the DPM, which is the detection positive minutes, which in this case we filtered for other citation. And then we've got a thing that says N all, And N all is the total number of clicks for that time period, for that, in this case, for that day. So, you know, these are in the tens of thousands or hundreds of thousands or even millions of clicks that you might get in one day. And then the last column is minutes on. So that tells you how many minutes the device was on for that period. Generally, apart from the first minute and the last minute, it would normally say 1,440 because that's how many minutes there are in a day, and therefore that's how long it's on for. The start minutes on is going to be the fraction of that day from when it was started, and then the end is going to be the fraction of the day up until the point where it was switched off, or when it was cropped, actually, when the file was cropped. Okay, thanks, Alexander. So including unknown clicks. So yeah, the unknown clicks, the clicks from everything is the N all. So that's not just clicks that the software has said are part of a train, that's clicks, full stop, I think. Nick will correct me if I'm wrong on that.
Yeah, no, that's correct.
Great. And yes, we'll be sending the recording, the 2 hours recording, a link to that from the Zoom cloud, so you can download that and view it whenever you want.
And Dan, there's a question about can I export a file with parameters of clicks? We'll cover that in the exporting session.
Okay, great. Oh yeah, sorry, Bruno, I missed that one. Yeah, great.
And then a question from Jeff there about mark trains.
Mm-hmm. Yeah, so what happened when you export the data, it will also be exported. So when you export the data, all the filters that you have in place at that point apply to the exported data. So when I mentioned about the marked trains included, and then you've got marked trains excluded and marked trains only, if those were selected when you click export, then that applies. So where I've got marked trains only, I'd marked 2 trains. I'd marked a boat sonar train and a porpoise train. If I exported at this point, because I don't have MBHF and boat sonar selected, I wouldn't actually get any trains, because the only ones that are filtered here are other cetacean, and I didn't actually mark those. So if everything was marked and then I clicked export, I'd get 1 porpoise train and 1 boat sonar train. So I'd probably get a total of 2 detection positive minutes over the whole period exported. So yeah, you just have to be really careful that you check what filters you've got in place when you click the export, because they will all apply at that point. There is the other export option that I mentioned, which is the detections and environments. That will give you a column for MBHF and other cetacean and boat sonar. So if you wanted to export DPM for all of those, it's kind of a quick way of doing that without having to do DPM and then do 3 different exports and then combine them. You can get those all in one go. But just bear in mind that if you had different filters that you wanted to use for MBHF to other cetacean, that wouldn't work, because it would apply whatever filters you have in place to all of them. But if that isn't the case, then you can just go ahead and click that and it will give you a column for each. It also gives you lots of other information about the deployment and the environment, a thing called minutes lost. So the pod will there is a kind of a maximum number of clicks that it will record in a minute. This is basically to save itself in very noisy environments from overloading well, not overloading, but for recording too much data, which is going to use your batteries up quicker and fill your card up quicker. So in the export, it will tell you the percentage of time that's been lost in the deployment due to this maxing out of a minute. So it will get to a particular point. Doesn't happen very often actually, but in a very noisy environment, say like where that pod was bouncing around in the surf, it could happen. You'll see the data suddenly stop. In fact, you can probably see that if I click 100 minutes. Actually, no, we won't do that. We won't do that. But yeah, you would see the data suddenly stop at a particular point in the minute, and then when it reaches the threshold of the next minute, it would then start recording normally. So you won't lose any more than that minute when it was noisy until it hits the threshold again. Okay, so last opportunity to ask any questions in the session, and obviously if you have any questions that you think of afterwards, just email them over to us and we'll reply as soon as we can. And of course, we'll share the recording with you when that's available on Zoom. No problem at all, guys. Glad it's been helpful. Great. Well, yeah, thank you. If we don't have any other questions on the course, just thank you all for coming and giving up your time. Yeah, it's been great to have you all, and it's it's nice to have a different communication other than email with people that we talk to regularly. So nice to see some of your faces as well. Yeah, and thanks Nick and Sibylla for your help and assistance. Always appreciated. And yeah, that's us done. So yeah, if everyone's happy, we'll finish now. And like I said, any questions, send them over and we'll get back to you. But yeah, just yeah, thanks everybody, and enjoy your day. Ours is coming to an end.